Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on sequential circuit flip-flops, JK and T flip-flop. First, what is mean by sequential circuit? Sequential circuit are quite different from combinational circuit in the sense that they employ memory elements. A sequential circuit provides the output based on current inputs as well as prior inputs. Therefore, it is more functional. It consists of combinational and sequential. External input can be given to combinational circuit, which can produce the output as external output. From the combinational output, the next state can be connected to your memory element. That is nothing but internal inputs, which can produce as the internal output that can be connected to your combinational circuit. Next one, combinational versus sequential circuit. Combinational and sequential. Combinational output depends on the current inputs. Sequential output depends on both current inputs as well as path states. It does not require memory elements in combinational circuit. It required memory elements like flip-flops, latches, etc. in sequential circuit. Combinational circuit output is intermediate based on input changes. Sequential circuit output is dependent on clock pulses and previous states. Combination low clock pulse is required. Sequential circuit required a clock signal to synchronize these state changes. Next one, flip-flop. Flip-flop is a circuit that maintains a state until directed by input to change the state. A basic flip-flop can be constructed using 4 NAND and NOR gates. Flip-flops is popularly known as the basic digital memory circuit. It has its two states as logic 1 and logic 0. Flip-flop is a sequential circuit which consists of single binary state of information or data. The digital circuit is a flip-flop which has two outputs and are of opposite states. It is also known as bistable multivibrator. Now we can compare latch with flip-flop and latch. Flip-flop is a bistable device. It has two stable states that are represented as 0 and 1. Latch is also a bistable device whose states are also represented by 0 and 1. Flip-flop is a edge triggering device. Latch is a level triggering device. Flip-flops forms the basic building blocks of many sequential circuit like counters. Latch can be used for the designing of sequential circuit but are not generally preferred. Flip-flop or have a clock signal. Latch does not have a clock signal. Flip-flops can be built from latches. Latches can be built from gates. Types of flip-flops. It consists of 4 types: SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. SR set reset flip-flop. JK flip-flop is the another version of SR flip-flop. D is nothing but delay flip-flop. T is nothing but toggle flip-flop. Next one, in JK flip-flop, the basic structure of the flip-flop which consists of clock, clear and a preset, which can produce the output as Q and Q bar. This is the basic block diagram of JK flip-flop. It consists of J and J, clock signal and clear, preset, and which can produce the output as Q and Q bar. This is the basic logic diagram of JK flip-flop. It consists of 4 NAND gates, J and K as input. Clock signal can be given to both, which can produce output as Q and Q bar. The Q bar can be connected to your J, Q can be connected to your K. This is the characteristics table of JK flip-flop. Clock can be given as 0. JK flip-flop XX, Qn plus 1 will be memory. When clock is high means for 0 0 0 1 1 0 state 1 1 state. 0 0 means memory. 0 1 0, that is reset state. 1 0 set state. 1 1 means toggle. Now we can see the excitation table of JK flip-flop Qn. When JK Q000 means Qn plus 1 0. 001 means 0, 0101, 0111, 1001, 101 Qn plus 1 0, 1110. See, based on this excitation table, we are going to derive the Karnaugh map for JK flip-flop. For deriving, we can get the Boolean expression as Qn plus 1 is equal to J into Qn bar plus K bar into Qn. Next one, T flip-flop. T flip-flop consists of data input, clock input and two outputs Q and Q bar, that is nothing but complement of Q. It consists of single input T, clock signal, preset, Q, clear and then Q and Q bar. Q bar is nothing but complement of Q. This is the basic logic diagram of T flip-flop. It consists of, we can giving the single input for both the NAND gates. It consists of 4 NAND gates which can produce output as Q and Q bar. Next one, excitation table of T flip-flop Qn T Qn plus 1. 0 0 means output will be 0. 0 1 means 1. 1 0 1 1 1 0. 1 1 means toggle. For this Qn plus 1, we are going to derive the Karnaugh map. We can get it as your Qn plus 1 is equal to T into Qn bar plus T bar into Qn. Next one, we can see the another applications of flip-flops. It is used in data storage, data transfer, registers, memory. In data storage, the flip-flops are used in data storage to store the binary data temporarily or permanently. Data transfer means flip-flops are used for data transfer in different electronic paths. Registers are moved from the array of flip-flop which are used to store the data temporarily. Memory means are the main components in the memory unit for data storage. Now we can see the assessment. DAS are quite different from combinational circuit in the sense that they employ memory components, sequential circuit. Compare combinational and sequential circuit. Combinational circuit based on past inputs, sequential circuit based on past inputs as well as previous inputs. A combinational circuit, it does not have a clock signal. Sequential circuit have a clock signal. Combinational circuit, it has have a memory element. Does not sequential circuit required memory elements. List the types of flip-flops. It consists of 4 flip-flops: SR, set reset flip-flop, JK flip-flop, and then D flip-flop, delay flip-flop, and then T flip-flop, toggle flip-flop. Compare latch and flip-flop. A flip-flop is a edge triggering device. Latch is a level triggering device. Flip-flops are built from latches. Latches are built from gates. The T flip-flop consists of dash and 2 outputs dash. It consists of single input, clock input, and 2 outputs Q and Q bar. Q bar is nothing but complement of Q. Outline the characteristic equation of JK flip-flop. Therefore, Qn plus 1 is equal to J into Qn bar plus K bar into Qn. In for the applications of flip-flops, it is used in memory units, registers, shift registers, storage registers, counters, frequency dividers, etc. Thank you.